do some introduction. In the previous units, we learned that the one-to-one correspondence between the test of the statistical hypothesis and the test. In a given situation, there can be several critical regions that of the specified size. A question that naturally arises is which of them can be considered as the best in the given context and how to find it. These issues are considered in the present unit. So in this unit, we can take the suppose x follows a binomial distribution of the we are taking the parameters phi comma theta to say h is equal to theta by 2 h naught and null hypothesis h theta not equal to 1 by 2 h1 theta is equal to 3 by 4 based on a single observation. So phi comma theta తీసుకుంటే ఆ రెండింటిని observations theta తీసుకుంటే binomial distribution లో you can take an h naught theta is equal to 1 by 2 h naught theta is equal to 3 by 4 we are taking here. So P of x comma theta. So P of x comma theta no manam NCP condition also phi cx we are writing here. See here phi cx theta power x and 1 minus theta. At p power x and q power 1 minus x. This is a fundamental formula. So phi cx theta power x and 1 minus theta phi power x. So x is equal to 0, 1, 2, 3, 4, 5 and so on. We are taking here. So for different values of the x probability mass functions under h1 and h1 are obtained or given the present tables here. Px is equal to x comma 1 2. So we are finding the values x comma 1 2 that is 0.0313, 0.1563, 0.3125, 0.3125, 0.16563, 0.313. 3 by 4 we are substituting in the above equation. So 3 by 4 0.0010, 0.146, 0.0879, 0.2637, 0.3955, 0.2373 and 0.319934 2813 అంటే మనం ఇందులో వాల్యూస్ ని మనం సబ్స్టిట్యూట్ చేస్తున్నాం 5cx లో x లో 1 కమా 1 by 2 x లో 1 కమా θ is equal to 1 by 2 వాల్యూస్ సబ్స్టిట్యూట్ చేస్తే మనకు కావాల్సిన వాల్యూస్ ఇక్కడ రావడం జరుగుతుంది. సో ఇఫ్ వి టేక్ c1 is equal to 0 c2 is equal to 5 for the both the these size of the test 0.0313 is equal to 1 by 32. So 0.0313 మనం సింప్లిఫై చేస్తే 1 by 32. However the power of the test associated with c1 is 0.0010 while that with C2 is equal to 0.2373 here. If C1 is taken in the critical region, so C1 is taken in the critical region, the probability committing on errors is more than the probability of the right decision. With C2, this is not the case. So we are taking that the probability C1 is equal to 0.0010. C2 values in the last column we are taking here x3 by 4 and x1 1 by 2. X comma 1 by 2, this is values are given. So we can observe that x is equal to 5 attains the under 1 by 2, 3 by 4 and 5 by 4 attains the maximum value in the 5 by 4. The criterion provides idea how to define and how to find the best critical region here. So best how after hereafter we adopt the following notation of x comma theta, probability mass function and probability density function we are taking here. Probability mass function, probability density function of theta belongs to h, theta 0, theta 1 of the random variable under consideration where theta is an unknown parameter we are taking here. So we are interested in testing hypothesis h naught is equal to theta is equal to t naught. So again is a simple alternative theta is equal to theta 1. So what is the best critical region? So best critical region, a critical region C star is called as the best critical region of size less than or equal to alpha 0 less than alpha less than 1 if it goes the maximum power. So alpha 0 less than alpha less than 1 if it has go to the maximum power we are taking here. So probability of x1, x2, x3 and so on xn belongs to C star by slash theta naught less than or equal to alpha. For any other critical region C1 satisfying the above condition, probability of x1, x2, x3 and so on xn belongs to C star by theta 1 greater than of probability the condition we are taking here x1, x2, x3 and so on xr belongs to C1 by theta 1. Likelihood function of the sample. Suppose x1, x2, x3 and so on xn is a random sample of size n from x. The joint probability mass slash density of x1, x2, xn is known as likelihood function of the sample. This is denoted by x1, x2, x3 and so on xn comma theta. So that the joint probability mass function we are taking here known as likelihood function x1, x2, x3 so n, so denoted by small x1, x2, x3, x4 and so on xn comma theta we are writing here. So let L naught x1, x2, x3, xn is equal to L is equal L into x1, x2, x3, and so on, xn theta naught, and L x2, x1, x2, x3, and so on, x naught, L into x1, x2, x3, and so on, xn theta 1, denote the likelihood functions under the null hypothesis HO under the alternative of hypothesis H1 respectively. So therefore, Neyman-Pearson lemma. Let alpha be positive value. So such that Neyman-Pearson lemma lo 0 less than alpha less than 1 and L0 and L1 is denoted the likelihood functions the sample observations. So here under HO and H1, so under HO, H1 and null hypothesis and alternative hypothesis, it is a critical region is C. So what is the critical region? Already I told you critical region is the function. So probability of x1, x2, x3 and so on, xn, EC by slash of H0 null hypothesis. So less than or alpha is exists in the constant k greater than or equal to 0. So L by LD greater than or equal to KLO. So that is the first function and less than or equal to KLO also. So first one, the second condition is belongs to C star. The second condition belongs to as slash by C star. The C star is the best critical region of size alpha. In H0 theta is equal to 0 and against alternate hypothesis theta is equal to theta 1. So optimal can be omitted. So what is the proof of the Neyman-Pearson lemma? We have to learn here. If C star is the only critical region that satisfies the above conditions, we have nothing to be proved. So satisfies the above condition, then we have nothing to be proved here. Let C1 be any arbitrary critical region satisfying. We have to show that probability of x1, x2, x3, and so on. Xn belongs to C star by theta 1. Greater than or equal to probability x1, x2, x3, xn. అంటే దాని గ్రేటర్ దాన్ theta 1 తీసుకుంటే ఇక్కడ theta 1 తీసుకుంటాం కానీ అక్కడ C star condition C1 condition అనేది less than or equal to condition అయినట్లయితే we show that assuming that the x continuous is the random variable. But even though let us denote here integration of L x1, x2, x3, x4, and xn. That is dx1, dx2, dxn. See here, all of you. So this is dx1, x2, x3, xn. So dx1, dx2, dxn. This may be treated as integration of A, L of A, B of x. Consider delta probability x1, x2, x3, xn belongs to C star by capital theta 1 minus probability x1, x2, x3, xn by belongs to C1 by theta 1. So integration of e power x L1 dx minus integration of C1 L1 dx bar we have to show that delta greater than or equal to 0. But the condition we have taken here C star by n C1 union C1 C1 as the complements of C1 C1 star C intersection of C1 C star intersection of C1 bar. So both the bars we are taking the Neyman-Pearson lemma. Very important question. Delta greater than or equal to 0 we are taking here. C star is equal to C star n in the bracket C1 union C1. The C1 union C1 into C1. But C1 bar is complement of C1. It is a complement of C1. But C star integration intersection of C1. C star intersection of C1 union of C star intersection of C1. C star intersection of C1 union of C star intersection C1 we are taking here. C1 C1n C star union C bars are అంటే మనం C star లో C star bar లో ఉన్నటువంటి వాటి వాల్యూస్ ని వీఆర్ యూనియన్ వీఆర్ క్లబ్బింగ్ దట్ వాల్యూ యూనియన్ అంటే 1 2 3 4 5 6 1 2 3 in A 4 5 6 in B we are union means 1 2 3 4 5 6 but intersection is a different the common values we have to taking here intersection C1 intersection C star union C1 intersection C star. So delta is equal to integration of C star integration of C1. So L1 dx plus integration of C1 intersection of C1 bar L1 dx we are taking here. So integration of C intersection of C star L1 dx plus integration of C intersection C star L1 dx. అంటే C intersection ఇక్కడ చూడండి Komal and another one was Bhargavi. See here. So C intersection of C star, C intersection of C star, both are same, but L1 dx, this is also L1 dx. See here, this is the integration of C star. C, just a minute. C intersection C star, C intersection star star. So here also C intersection of C1 L1 dx. C1 intersection of the different of the integration part, first one. So we can take the L1 dx. So C star intersection C star intersection of C1 bar is not equal to C star and L1 greater than equal to co for K choke co for x belongs to C star using this. Using this, delta is equal to k integration of c star integration of c1. So integration of c star c LOD x and LOD x integration of c1. So therefore k constant by this was integration of c LOD x integration of c1 LOD x. So this is the condition for Neyman-Pearson lemma. So this is the condition of the critical region. KLO function we are taking here, and also we are proving this one by the Neyman-Pearson lemma theorem of k integration of CLOD x minus integration of CLOD x. Problems based on Neyman-Pearson lemma. Suppose x has normal distribution with mean theta and variance 1. Find the best critical region of size alpha. Testing x naught is equal to theta is equal to t naught against h1 theta is equal to theta 1 when theta 1 greater than or equal to theta. Are you understanding Bhargavi and Komal?
Yes, sir.
ఇది ఇది Neyman-Pearson lemma ఇస్తారు exam అడగొచ్చు maybe. You have to prepare. Any doubts, ask me and write it. Okay. Then the problems on f of x comma theta 1 by 2 root pi. So what we have to take here, 1 by 2 root pi, this is a fundamental formula, e power minus 1 by 2 x minus theta whole square, greater than minus infinity x less than infinity, minus infinity less than x greater than less than లో తీసుకుంటాం, minus greater than లో తీసుకుంటాం, less than లో తీసుకుంటాం, condition 0 greater than otherwise condition. Suppose we are taking here x1 x2 xn is a random sample of size So suppose x1, x2, xn is a random sample of size n from x. Let x1, x2, x3 and so on xn phi I is equal to n. Therefore, f of xi is equal to theta we are taking here. So therefore, just a minute, please. So 1 by 2 pi whole power n by 2 e power minus 1 by 2. And this is a simplification of this one we are taking here. F of I is equal to 1 xi theta. F of I is equal to xi theta we are taking here. So f of xi theta. So therefore 1 by 2 pi whole power n by 2. This the condition is simplifying here. E power minus 1 by 2 of xi power minus 1. And the x1, x2, xn theta all over the simplify చేస్తే ఈ విధంగా రాసుకోవచ్చు. So C star of best critical region BCR size of alpha. So BCR is the best critical region we are taking here. So L naught is equal to 1 by 2 pi whole power n by 2 e power minus 1 by 2 e of xi minus theta whole power 2. L1 1 by 2 pi n by 2 e power minus 1 by 2 xi minus theta 1. అంటే ఇక్కడ L0 తీసుకున్నాం కాబట్టి ఇక్కడ చూడండి L0 తీసుకున్నాం కాబట్టి theta తీసుకున్నాం. ఇక్కడ L1 తీసుకున్నాం కాబట్టి theta 1 తీసుకున్నాం. So L1 by L0. So e power minus 1 by 2 summation of x1 minus theta 1. So whole square sum 1 by 2 summation of xi minus theta whole square రెండింటిని బట్ డివిజన్ లో రాస్తే మీది తీసుకెళ్ళిపోతున్నాం పవర్ ఆఫ్ మైనస్ 2 లో 3 లో తీసుకుంటాము. E power minus 1 by 2 minus 2 theta 1 summation of xi e power minus 1 by 2 minus theta 1 summation of xi plus n theta 1 square 2 theta 0 summation of xi minus n theta 0 whole square. So n power n x bar theta 1 minus theta 0 e power minus 1 by 2 theta 1 square minus theta 0 square of n comma theta naught and theta 1 are known values here. So e power minus 1 by 2 theta 1 minus theta 1 square minus theta 0 square is known as positive constant here. There are x1, x2, x3, xn for which L1 by LD is equal to 0. For Neyman-Pearson lemma cannot take k naught. For k greater than 0 we are taking here x1, x2, x3, xn, L1 by L0 greater than k. So x1, x2, x3, xn log L1 by L0 greater than of log e power k. So see here x1, x2, xn, the n is the b. So nx bar is equal to theta 1 minus theta plus log e a greater than or equal to log e k. x1, x2, x3, xn, x bar. So therefore log e power k log e power a n into theta 1 minus theta 0. So see here in this condition log b is equal to log e power k minus log e power a. And then in simplification log e power k log e power b by n into theta 1 minus theta naught. We have find b such that probability h naught is true, x equivalent to n theta naught 1 by n. So probability x bar minus theta naught 1 by root n. So greater than or equal to b minus theta naught 1 by root n. So these conditions are we are arriving here. అంటే ఎక్స్ నాట్ అంటే ట్రూలో తీసుకుంటే ఎక్స్ మైనస్ ఎక్స్ బార్ బై టీటా నాట్ 1 బై రూట్ ఎన్ గ్రేటర్ దెన్ ఆర్ ఈక్వల్ టు బి టీటా నాట్ 1 బై రూట్ ఎన్ లెస్ దెన్ ఆర్ ఈక్వల్ టు ఎక్స్ నాట్ బై టీటా నాట్ 1 by root n01 we are taking here. So we can find the use normal tables. If theta 1 greater than less than 0, we can best critical region we have to take that x1 x2 equivalent to x greater than less than a constant. Second problem ఒకసారి చూడండి. I will just verify 1 minute. ఒకసారి చూడండి భవానీ అండ్ కోమల్ సెకండ్ ప్రాబ్లం ఒకసారి చూడండి. నేను మళ్ళీ వెరిఫికేషన్ చేసి చెప్తా. ఓకేనా?
ఓకే సార్.
Just a minute. Komal, I will come back within 1 minute, okay?
ఓకే సార్.
So, sorry, 5.4.2 is a probability of mass function x is p of x is equal to theta ncx theta power x 1 minus theta n power x theta less than 0 less than theta less than n is equal to 0 1 2 0 otherwise x1 x2 x3 be random sample size of from x that x1 x2 x3 xm అంటే ఇక్కడ ఏమైతుంది పై ఆఫ్ n is equal to p x1 theta pi of I is equal to 1 x nc x so theta into xi 1 minus theta n minus m summation of xi. So L1 by L0, L1 by L1 by L0 we are taking here. So theta 1 summation of xi 1 minus theta 1. So 1 minus theta 1 that is n minus nm summation of xi. Mn summation of xi. Let us see C star is the BCR. Best critical region of the points L1 by L0. L1 by L0 is greater than K. So theta 1 by theta naught EXI 1 minus theta 2 1 minus theta naught Mn minus epsilon xi x greater than or equal to K we are taking here. See here. So therefore theta 1 by theta naught EXI 1 minus theta 2 1 minus theta naught Mn epsilon xi అంటే ఆ కండిషన్ ని కనుక మనం ప్రూవ్ చేయగలిగితే వేర్ greater than 0 log L1 by L0 greater than or equal to log EK. Summation of xi is equal to log theta 1 by t naught plus mn అంటే ఈ ప్రాబ్లం ఇక్కడ సింప్లిఫై చేస్తే mn summation of xi log 1 minus theta 1 by theta naught greater than or equal to log EK. Summation of xi log theta 1 by t naught minus log 1 minus theta 1 by 1 minus theta naught ఇక్కడ తీసుకొస్తున్నాం మనం దాన్ని greater than or equal to log so k into 1 minus theta naught by 1 minus theta 1 into mn. So since theta 1 greater than theta naught the best critical region we are taking here alpha. So x1 x2 x3 xn the x bar greater than b is equal to log e k into 1 minus theta naught by 1 minus theta 1. So that is a simplification of m log e we are taking from the above equation. So m log e the best critical region m log e theta 1 minus 1 minus theta naught. So theta naught of 1 minus theta. We find b such that x greater than or equal to b oblique h naught less than or equal to alpha. In case of discrete distributions, it is not always possible to say a test whose size is equal to alpha. So one problem we have to see here. See here, x as a Poisson distribution of the parameter of the best critical region. Obtain the best critical region of size of testing. Lambda is equal to lambda against h1 lambda is equal to lambda. Solution. E lambda lambda power x x factorial e power lambda. This is e power lambda lambda power x lambda greater than 0 x is equal to 0 1 2. Otherwise we are taking here. Suppose x1 x2 x3 so on xn is the random sample size of n from xl x1 x2 x3 so on xn lambda pi I is equal to 1 to n p xi lambda we are taking here. So therefore so p xi lambda మనం ఏం చేస్తాం ఇక్కడ సో అంటే ఇక్కడ ఈ random sample e power lambda lambda power x n by pi is equal to p x pi lambda. So e power n minus lambda lambda e power xy pi is equal to 1 x pi xi factorial. So therefore C is the BCR size alpha then the power then per point in C L1 by L0 greater than or equal to K or e power minus n lambda 1 lambda power xi. So my e power of minus n lambda 0 is a summation of xi greater than or equal to K we have taking here. See here. For k greater than 0, minus n lambda 1 minus lambda naught, simplification of k greater than 0 plus summation of xi log lambda 1 by lambda naught greater than or equal to log e k, summation of xi log lambda 1 by lambda naught greater than or equal to log k plus n into lambda 1 minus lambda naught. So x greater than or equal to b, where b is equal to 1 by n log k plus lambda 1 minus lambda naught by log lambda 1 by lambda naught we are taking here. We have to find b such that we have to find b such that probability of x bar greater than or equal to b by h naught greater than or equal to less than or equal to alpha. We are taking the condition here only. What is unbiased critical region? So in conducting a test of statistical hypothesis, you want to reject HO if it is false. On the other hand, if HO is true and it becomes necessary to reject HO, అంటే మనం we want to reject the HO అయితే false అవుతుంది. But behind that HO is true. It is necessary reject HO is done very rarely. True అయినప్పుడు రిజెక్ట్ కావడం అనేది చాలా రేర్ కండిషన్ లో ఉంటుంది. సో ఇన్ క్రిటికల్ రీజన్ లో so a test procedure having the above property is called as unbiased test. The corresponding critical region is called as unbiased critical region. A critical region is C is said to be as unbiased critical region. Probability of x1, x2, x3 and so on. Xn belongs to C by theta 1 greater than or equal to probability C x1, x2, x3 so on. Xn belongs to C by theta 0. So these conditions are we are taking here. x1, x2, x3 so on. Xn belongs to theta 1. x1, x2, xn belongs to theta 0. That is 1 minus beta less than or equal to greater than or equal to delta. This is the best critical region size alpha obtained by NP lemma is unbiased critical region we are taking here. Randomized test function. So in the randomized test function we are taking here. In the randomized test function, if so we observe that L1 by L0 is the maximum level is x is equal to 5. So we take that in randomized function C1 is equal to 5 as the critical region, then the size of the critical region is alpha is equal to 0.0313. If we include that x is equal to 4, L1 by L0, and the next highest value is 5 is there, we can write the 4 comma 5 as the critical region is the size of the test alpha 0.0313, the 0.01563, and the 5 values is 0.186. Suppose we fix that alpha is equal to 0.05. In this case, alpha 1 less than alpha 2, and alpha 1 less than alpha less than 2. We can see all these critical region whose size is exact equal to alpha. There are two options available to us to consider C1 is equal to 5 as the best critical region of size alpha 1 given by NP lemma. This has got the maximum power amongst the all critical region size less than or equal to alpha 1. The second option is go in for randomized test functions. What are the randomized test functions we are taking here? Suppose phi is equal to x r power n. Function is defined as r power n to r power n. It is closed interval of 0, 1. We are taking here. So we reject the new hypothesis HO. So we are taking the hypothesis reject HO. Hypothesis HO. The probability phi of x do not reject HO with the probability of 1 minus 5. The condition of x bar. The function of phi of x is called as and a randomized test function. So randomized test function, the probability of phi of x bar do not reject HO, but the probability of 1 minus x bar, the function. Therefore, then the phi of x is called as randomized test function. In this case, we do not divide the space generated by the sample points into two mutually disjoint regions and reject HO whenever the sample points belongs to the critical region or rejection region. Based on the value of phi of x bar equal phi of x1, x2, xn, we sometimes reject or do not reject HO we are taken. There can be several functions. There can be several functions phi of x bar r power n to 0, 1. Suppose on a particular function such that phi of x is equal to x1, x2, xn belongs to C is equal to 0, x1, x2, xn does not belongs to C. So then we can see that the test based on the critical regions become special cases of and belongs to C ఒకటి does not belongs to C. రెండు కండిషన్స్ కనుక తీసుకుంటే phi of x లో అది ఒకటి క్రిటికల్ రీజన్ స్పెషల్ కేసెస్ ఆఫ్ randomized టెస్ట్ ఫంక్షన్స్ గా మనం చూడొచ్చు. సో ఇంతకుముందు చెప్పాను నేమాన్ పియర్సన్ లెమ్మా is a randomized test function y of x square is a randomized function with that L1 KLO. So therefore phi of x bar is equal to gamma x 0 less than gamma x less than 1 for L1 is equal to KLO. So if L1 less than KLO, then phi of x is equal to a randomized test function of alpha. So therefore phi of x is equal to x greater than 4. But the condition of gamma alpha minus alpha I. So but ఇక్కడ ఈ x greater than 4 తీసుకున్నప్పుడు alpha I minus alpha 2 minus alpha 1. So that is x is equal to 4 or x less than or equal to 4. So if I have x into 1 alpha 1 plus alpha minus alpha 1, alpha 2 minus alpha 1 into alpha 2 minus alpha 1. From the above definition, we are taking this is alpha 2 minus alpha 1 is equal to 0. This is also so that we can have the test function exactly equal to alpha. Note, if we take h0 0 belongs to hi 0 belongs to hi, the probability functions committing type 1 and type 2 errors. So yesterday I told type 1 and type 2 errors. Alpha theta is equal to E0 phi of x1 x2 so on xn1 theta belongs to h0 b into theta 1 minus c theta e of phi of x1 x11 and x2 x12 and so on theta belongs to h1. That is null hypothesis. That is null hypothesis. sufficient of alpha theta of size of the test function alpha of x bar. So this is the fundamental problems of this one summary. So against the critical region, region size scale, the alpha 0 less than alpha less than 1, all positive constant. The critical region having the maximum power is called best critical region. Neyman and Pearson lemma is to determine the best critical region. In the case of discrete distribution, we may not have the best non-randomized test whose size is exactly equal to the specified test of alpha. For unbiased test, power of test greater than equal to size of the test. 1 minus beta greater than alpha. The test bounded by using NP lemma is unbiased test. NP lemma is an unbiased test. Mind it, this is unbiased test. A non-randomized test is specialized the randomized test. This is a fifth unit. This is a, you have to learn in this unit. This is clear. This is this one. Clear, Komal?
Clear, sir.
Okay. ఇంకెవరు ఉన్నారు ఆమె ఎవరు భవానీ test for single mean and proportion. So large sample test for single proportion, large sample for single mean, small single test for single mean, assumption made in small sample test for single mean. Introduction. Objectives to carry test for the single proportion of the largest samples, to carry the largest sample for single mean, single test for single mean. See a large sample test for single mean proportion. Consider a Bernoulli population with the probability of success P. Consider a Bernoulli population with probability success P. We are interested in testing of hypothesis. In the design of experiments also in the 5th semester you learn the population of proportion success P is equal to P naught. So H1 we are taking here P greater than P naught or P less than P naught or P naught equal to P naught. Only one of these three is to be taken. P greater than P naught, P less than P naught, P naught equal to P naught. So the nature of the alternative can be taken depends upon the given problem. We have already learned that P naught equal to P naught, two-side alternative. P greater than P naught or P less than P naught are single-sided. Suppose the level of significance is alpha we are taking here. Based on a random sample size and take from the above population, let the sample proportion success be P is equal to X by N. Here X is the number of success observed the sample here. So therefore, in case of the large samples, follow the normal distribution. In the 3rd semester, I think you are taking the 2nd semester or 3rd semester, you learn the normal distribution. Am I correct? At a mathematical moment inequality, you learn this one. So the variance we have to take here, see all of you, PQ by NQ is equal to 1 minus P. See here, this is the one shaded area. This is alpha by 2 to minus by 2. This is alpha by 2. Z condition, the left side is minus by 2. This is positive by 2. The P naught equal to P naught. So therefore, Z is equal to B minus beta minus P under root of PQ by N equivalence to N0, 1. Where under HO Z P minus P naught by under root of P naught Q naught equals to N0. అంటే ఇక్కడ మనం వాల్యూస్ రాస్తున్నాయి P ని ఇదంతా B naught ఇది B naught minus P తీసుకుంటాము under HO లో P minus P naught by Q naught by N equals to N01. So the alternative side is P naught equal to P naught equal to P naught. So since normal distribution is symmetric, the two region each side alpha by 2 lie on the other side of the line of the symmetry Z is equal to 0. If we have large positive value of small negative values in the statistic Z under HO, this actually goes in favor of the alternative. ఎందుకంటే small negative values is the favor gaane botadi alternative ku that the data relatives really supports H naught. We expect a value close to 0. So we do not reject H1 and of the value of statistics false with them Z minus Z alpha by 2 and Z alpha by 2. If Z calories less than Z alpha by 2, so less than or equal to unte we do not reject HO. Otherwise, less than unte reject చేయకూడదు, greater than unte reject చేయొచ్చు. So this is the decision of the criterion rule we'll be using here. So you see here, this is the left side and this is the right side. This is the positive, this is negative. In this case of the rejection area is one of the line of the symmetry. Komal, we can learn in the 2nd semester na mathematical moment inequality.
Yes, sir. Yes, sir.
Yeah. So left side and right side తీసుకుంటే less than తీసుకుంటే do not reject చేస్తాం, greater than తీసుకుంటే reject చేస్తాం. So if we got a very large positive for Z under H with the favorite of alternative P greater than P naught, a small negative values are P less than P naught. So if Z calorie is less than Z naught, Z alpha, We do not reject HO, otherwise we reject HO here. Note, a test statistics is a statistics which is determined from the sample data depending upon the value of the test of statistics decision. అంటే స్టాటిస్టిక్స్ లో డిటర్మైండ్ ఆఫ్ ద శాంపిల్ డేటాను మనం వాల్యూ ఆఫ్ ద స్టాటిస్టిక్స్ లో డిసిషన్ తీసుకుని నల్ హైపోథిసిస్ కావచ్చు, రిజెక్షన్ ఆర్ నాట్ టేకెన్ కావచ్చు. అది మనం ప్రాబ్లం చేస్తే కానీ మనం చెప్పలేం స్టాటిస్టికల్ ఇట్ ఇస్ శాంపిల్ డేటా అని. ద క్రిటికల్ రీజన్ ఈజ్ ఆల్సో called as a rejection region. It said the value of such statistics is null hypothesis will be rejected. Most important problem I am telling, note it. A manufacturer of laptops claims that 60% of the people of laptops as a company sample of 40 people, 19 are using laptops of the company. Is the claim of the manufacturer is valued? Sudham. So first we are interested in testing. Raskocha. So 60% and 0.06.
Yes, sir.
So the claim of the manufacturer against the population of the P less than P not alpha is equal to 0. వాడు ఏమి ఇవ్వకపోతే నేను చెప్పినాను 0.05 తీసుకోమని నల్ హైపోథిసిస్ ఫార్ములా వాడుతున్నాను నేను ఇక్కడ. So alpha is equal to 0.05. Null hypothesis true. Z is equal to P minus P naught by under root of P naught Q naught by N. Standard normal distribution we are taking here. So therefore Z calorie is less than Z alpha. We do not reject it. So otherwise we reject it. చూద్దాం less than వస్తుందా greater than వస్తుందా. సో శాంపిల్ ఎంత ఇచ్చినాడమ్మా వీడు? శాంపిల్ ఎంత ఇచ్చాడు? 40 ఇచ్చినాడు. ఒక్క నిమిషం కిందికి వెళ్తున్నాం. 40 ఇచ్చినాడు శాంపిల్. సక్సెస్ఫుల్ ఎంత ఇచ్చినాడు? 19 ఇచ్చినాడు. అవునా? 19 సక్సెస్ఫుల్ ఇచ్చినాడు. సో పిఎక్స్ బై 19/40 ఎంత? 0.475. సో పి అంటే ఎంత ఇచ్చినాడు ఇక్కడ? పి అంటే ఎంత వచ్చింది? 0.475. పి నాట్ ఎంత వచ్చింది? 0.6 ఇచ్చినాడు. ఎందుకు ఇచ్చినాడు ఇక్కడ? ద ప్రపోర్షన్ పి నాట్ ఈజ్ ఈక్వల్ 0.6 ఇచ్చినాడు. సో 0.6 into 0.4/40. సో టోటల్ ఈజ్ -1.3617. సో జెడ్ క్యాలరీస్ ఈజ్ 1. మాడ్యులస్ తీసుకుంటాం కాబట్టి 1.6137. 5% ఆఫ్ సిగ్నిఫికెన్స్ లెవెల్ మనం టాబ్లెటెడ్ వాల్యూ చూస్తాం అందులో. దట్ ఇస్ 1.645. అప్పుడు లెస్ దాన్ గ్రేటర్ దానా?
Less than.
So therefore we do not reject HO. Clear?
Sure.
ఇంకో ప్రాబ్లం చూద్దాం. ఈ టైప్ ప్రాబ్లమ్స్ అడుగుతాడు. Past experience reveals that 5% of the times items produced by a machine are defective. In a sample of 56 items produced by the machine, there are 8 defective items here. So we say that there are degradation in the performance of that machine. So here solve. We are interested in testing. P is equal to రాసుకోవచ్చమ్మా 0.05 రాసుకోవచ్చా? So P greater than P naught, alpha is equal to 0.5. Same formula applying. N is equal to 56 here. Sample size ఎక్కడ ఇచ్చినాడు? There are 9 అని 8 defective items అన్నాడు. ఇక్కడ 9 ఎందుకు రాసుకున్నా నేను? పాజిటివ్ మిషన్ ఇన్ శాంపిల్స్ ఆఫ్ 60. There are 8 defective items. ఇక్కడ 8 అమ్మా, ఇది 8. కోమల్ అండ్ అనదర్ వన్.
Okay, sir.
8 అని రాసుకోవాలి, తప్పు పడ్డది. 8. So therefore x by n 56/9 56/8 ఎంత? కాదు x అంటే 9/50 8/56 8/56
0.14 సంథింగ్ అట్లా.
అది ఇక్కడ తప్పు రాసినాము. సో 0.14 సంథింగ్ తీసుకున్నట్లయితే గ్రేటర్ దాన్ వస్తే రిజెక్ట్ HO, లెస్ దాన్ వస్తే యాక్సెప్ట్ HO. క్లియర్?
ఓకే సార్.
అదొకసారి చూడండి, తప్పు పడ్డది 6.2. Third one, it is known that 15% of the words used by a writer are Sanskrit origin in a sample of 75 words. Of that there are 17 words are in Sanskrit origin. So can we say that there is a change of the use of the words in Sanskrit origin? Test the hypothesis of 1% level of significance. ఎంత 15% అంటే ఎంత రాసుకోవచ్చు? 0.15 రాసుకోవచ్చా?
0.15.
There is no అది ఉంది కాబట్టి P naught equal to P naught అంటే ఆల్టర్నేటివ్ వైపు తీసుకుంటాం. ఇక్కడ 0.01 అన్నాడా? 1% లెవెల్ అన్నాడు ఇక్కడ, అన్నాడా? సో 0.01 అన్నాడు. ఫార్ములా ఇస్ ద సేమ్. P minus P naught under P naught Q naught by Pn అని తీసుకున్నాం మనం. శాంపిల్ సైజ్ ఎంత తీసుకున్నాడు వీడు? 75 17. 75 17/75 ఎంత వస్తుందో చెప్పు. 17/75
0.22667.
ఓకే, అది రాసాము. 0.2267 మైనస్ 0.15 ఏదో ఇచ్చినాడు పీజీ నాట్. సో ఆ ఏసీ సబ్స్టిట్యూట్ చేసాము, చేస్తే అది 1.85 వచ్చింది. 1.8 లో 5 చూస్తే టాబ్లెట్ వాల్యూ 2.5 అవుతుంది. జెడ్ మాడ్యులస్ ఆఫ్ జెడ్ క్యాలిక్యులేటెడ్ లెస్ దాన్ జెడ్ టాబ్లెటెడ్ లెస్ దాన్ వచ్చింది కాబట్టి వి డు నాట్ రిజెక్ట్ హెచ్ఓ. క్లియర్?
Yes, sir.
So large sample test for single mean we can learn here. So consider a population with finite mean, and variance sigma square. We want to test the null hypothesis. So HO, the population mean mu is equal to mu naught, a specified value against the population mean mu is equal to greater than mu naught, mu less than mu naught. Etline raskochu mu not equal to mu naught. Alternative hypothesis so greater than అయినా కావచ్చు, less than అయినా కావచ్చు, not equal to అయినా కావచ్చు. ఎందుకంటే ఇది ఈక్వల్ అవుతుంది, కాబట్టి ఇది గ్రేటర్ దాన్ అన్నా లెస్ దాన్ అన్నా నాట్ ఈక్వల్ టు కావచ్చు. ద నేచర్ ఆఫ్ ద ఆల్టర్నేటివ్ హైపోథిసిస్ depends upon the given problem here. So based on random sample size and taken from the above population, x bar be the sample mean, s square be the sample variable. So in large sample mean, x bar follows normal distribution is mu and variance sigma square by n. See z is equal to x bar minus mu by sigma by under root of n is a standard normal. This is a basic fundamental formula. Z is equal to x bar by mu sigma by under root of follow standard normal distribution under HO. X bar by minus mu bar by sigma under root of n. If the alternative two side and z calories less than or equal to z alpha by 2, we do not reject HO. Otherwise we reject HO. ఇంతకు ముందు చెప్పింది ఆల్టర్నేటివ్ హైపోథిసిస్ లో alternate of single sided modulus of z calorie less than z alpha, we do not reject HO. If the alternative single sided modulus of z calorie calculated value of z alpha, we do not reject HO. If the population of the variance sigma square is not known, then for the large sample we will use that s square and in place of sigma square place lo variance s square in the place of sigma square place s square vaadtam. So one problem we have to do here. Let the level of significance alpha is equal to 0.05. HY is true. The two test statistics Z x bar minus mu bar by summation of root n follow standard normal distribution. Z calories less than or equal to Z alpha by 2. We do not reject HO, otherwise we reject HO. Suppose n is equal to 100, sample mean x bar is equal to 58. So sample standard deviation 4. Since sigma value is not given, so in place of sigma 58 minus 60 రాసుకోవచ్చా? 2 కిలోలే 2 కేజీలే రాసుకోవచ్చు కదా?
Yes, sir.
రాసుకోవచ్చు. ఓకే. 58 minus 60 by 4 by 100 ఇచ్చిండు. ఎక్కడన్నా శాంపిల్ సైజ్ 100, 4 kgs లో 100 ఇచ్చాడు. సో అంటే డీవియేషన్ 4 kgs అన్నాడు. పాపులేషన్ లో ఇది మీన్ ఇచ్చినాడు, పాపులేషన్ ఇచ్చాడు, 4 kg ఇచ్చినాడు, 4 by root 100. సో మైనస్ తీసేస్తే 2 minus 2 అంటే 2 గెట్ క్యాన్సల్, 2 root by 100. సో -5 వస్తుందంట. సో మనం అందులో చూస్తే టాబ్లెటెడ్ వాల్యూ 5%, 2 సైడెడ్ టెస్ట్ లో చూడాలి, ఇది 1.96 వచ్చింది. Komal, I am audible? Komal, I am audible? Okay. So the population of 58 minus 60, 4 by root 100 minus 5. So for table value, 5% level of that is 1.96. The population is mean. Komal. Okay. Sample, another problem you have to do. A sample size of 50 students is found of a mean weight 67.47 inches. can it be reasonably recorded a sample size of large population which means 67.39? So inches the standard deviation of 1.2 inches. So population of mean population mu not equal to mu not is equal to 60.739 against mu not equal to 0.5, 67.39, 67.47. So therefore z bar z is equal to x minus mu not by sigma under root of n. So this is also same here. Z modulus of z calculated less than z alpha by 2. Do not reject HO, otherwise deduct HO. So 67.47 minus 67.39 by 1.2 ఇచ్చాడు ఇక్కడ ఇంచెస్ ఇంటూ రూట్ 50 ఇచ్చాడు. దాన్ని సింప్లిఫై చేస్తే మనకి 0.4714 వచ్చింది. ఈ 0.174 టాబ్లెటెడ్ వాల్యూ ఇస్తే 1.96. సో దేర్ ఫోర్ ఇట్ ఇస్ రిజెక్టా యాక్సెప్టా కోమల్? యాక్సెప్ట్ పవర్ పోయి వచ్చింది, దాంతో కొన్ని నిమిషాలు బ్రేక్ అయింది. ఓకే, స్మాల్ శాంపిల్ టెస్ట్ ఫర్ సింగిల్ మీన్. The test considered in the previous two sections, we have assumed that the site of the sample is large. There are no hard as rules is defined as large sample. In case of large sample, whether the underlying distribution, the test statistic we use approximation statistics of the form. This is a basic condition I told in the laboratory class also. Z is equal to T into T small t into E minus T SC of T, the standard normal distribution. In the size of the sample, not large, we now cannot use the abnormal approximation. We have to consider actual or exact sample distribution of statistics or consider test based on the exact sampling distribution. Assumption made in small sample test. So we make the following assumptions in the case of small sample test. The parent population from the sample is taken as a normal population. The given sample is random sample. The result of the normal population noted as the student of T distribution. See here, the sample test for single mean. Consider a normal population with mean mu and variance sigma square. You know that in general thing. We want to test HO, mean of the population mu is equal to mu naught, a given value. H1, one of the alternatives mu not equal to mu naught, mu greater than mu naught or mu less than mu naught based on the given problem we are giving here. So let the level of significance alpha. Suppose x1, x2, x3 and so on xn is a random sample of size. X1, x2, x3, so on xn is a random sample of size n. Take from the normal population. Let x bar be the sample of mean and s square be the sample of variable here. So if the population of sigma square is the known under HO, that x minus mu bar by sigma under root n follows standard normal distribution. We compare z calculated the tabulated value and take approximate decision we are taking here. So therefore, in case 2, the population variance sigma square is known under HO, T x bar minus mu naught s by under root of n minus 1 we are taking. Ante x bar minus mu naught under root of sigma n ikkada kuda s by under root of minus 1 x minus mu bar. We compare T calculated value with tabulated value corresponding n minus degrees of freedom specified level of significance. T calculated value is more reject HO, otherwise we do not reject HO. So instead of sample s square 1 by n summation of xi minus x bar whole square, so that the formula we are taking 1 by n minus 1 summation of xi minus x bar whole square, the unbiased estimate of a population variance pair, the test statistics x bar minus mu by s by under root n follow T distribution with n minus 1 degrees of freedom. Based on the following random sample from a normal distribution test, the hypothesis population 65 and variance sigma square. See here, you got a sample ఇచ్చాడు చూడండి, 62, 64, 67 ఇచ్చినాడు. They known as 65. మీన్ ఎంత ఇచ్చినాడు? 65 ఇచ్చినాడా?
Mean 65, sir.
Okay. Mean of the population that is mu 1 not equal. Sigma ఏమి ఇవ్వలేదు కాబట్టి 0.05. సిగ్మా స్క్వేర్ ఎంత ఇచ్చినాడు? 16 ఇచ్చినాడు. ఇచ్చినాడా?
16
ఇచ్చినాడు. So therefore, under the x minus mu naught by sigma root n is a standard formal distribution. So z calculated by less than or equal to z alpha, we do not reject HO, other we do not reject, we reject HO. sample size n is equal to n sample size ఎంత ఇచ్చిండు చూడు sample size ఎన్ని లెక్క పెట్టు
1, 2, 3,
4 5 6
10.
7 10 10 so here 60 68.6 minus 65 by 4 and 4 అంటే వాడు ఇచ్చినాడు ఏమి ఇచ్చినాడు 4 ఇక్కడ one normal distribution 65 and the variance known as 4 ఎట్లా వచ్చింది వానికి సిగ్మా స్క్వేర్ సిగ్మా
16.
అంటే రూట్ కడతాం కూడా 4 సో 3 0.2 సో 3 అంటే దీన్ని మనం టాబ్లెట్ చూస్తే 1.96 3లో 1.96 అంటే గ్రేటర్ దాన్ అంటే కదా
Greater than.
the population mean difference is 65 ఖచ్చితంగా ఈ టైప్ ఆఫ్ ప్రాబ్లమ్స్ ఎగ్జామ్ లో అడుగుతారు బాబు
Okay, sir.
based on the following random sample distribution ఇగో 51 52 53 55 57 56 50 సో నార్మల్ డిస్ట్రిబ్యూషన్ 58 ఇచ్చాడా 0.05 సిగ్మా స్క్వేర్ సో x minus mu naught by s by root of following distribution n is equal to 10 ఉన్నాయి చూడు 1 2 3 4 5 6 7 10 ఉన్నాయి 56 minus 20 58 by 3.2496 root of 10 minus 1 so it is minus 1.6617 so tabulated value that is degrees of freedom is 9 so 5% of significance 2.62 దానికంటే ఇది ఎక్కువ ఉంది కాబట్టి we do not reject it so clear
Yes, sir.
clear
Yes, sir.
okay when the size of the sample large size whatever the underlying we are normal distribution in larger samples we are formula z is equal to t into e minus t se of t for normal distribution we use the property of normal distribution the size of the small we consider test based on the exact actual sampling distribution Bhavani, are you understood Komal Bhavani Komal and respond please
Yes, sir. Yes, sir.
okay tomorrow we can study we can discuss tomorrow 6th 7th and 8th unit okay
Okay, sir.
run test of and rep discuss చేద్దాం thank you